A sudden burst of flame transforms soft iron into hardened steel. But reaching this critical moment requires fire, force, and absolute precision. The foundation of a wakizashi isn't always pristine high-carbon steel. Here, a weathered automotive leaf spring provides the raw mass. These thick suspension springs are factory-forged to endure constant cyclic fatigue, making them ideal stock for a resilient, shock-absorbing blade. The first step isolates the core material, stripping away decades of oxidized decay. Abrasive discs slice through the dense alloy, separating the usable central section from the heavily pitted exterior. Surface contamination must be entirely removed before the steel ever touches an anvil. Any residual rust hammered into the glowing metal would introduce hidden structural flaws, permanently compromising the blade's integrity under heavy impact. Once the profile is roughly established, the steel enters the propane forge. The intense, contained heat slowly brings the tight molecular structure to a plastic state. Softening the dense carbon alloy is the only way to prepare it for the heavy deformation required to shape a sword. After rough shaping under the hammer, the cooled steel meets the abrasive belt. This stage establishes the primary bevels and the blade's iconic curvature. High-speed grinding generates intense friction, so the craftsman must maintain a steady, even pressure to avoid localized overheating. Heat buildup here could inadvertently soften the steel before it ever reaches the quench. The geometry of the tip, or kisaki, dictates both its piercing strength and the visual balance of the entire weapon. Long, continuous passes along the belt ensure a uniform taper from the spine to the edge. A perfectly flat-edge geometry guarantees the blade will cut predictably and efficiently through a target. The transition between the cutting edge and the handle requires careful definition. A precise notch delineates the tang, which acts as the structural anchor for the sword. If this transition is left uneven or sharp, it creates a stress riser. A stress riser is a microscopic focal point where impact force could easily snap the steel in half. Hand files refine the mechanical cuts, ensuring the tang tapers smoothly to securely accommodate the collar and the wooden handle. A final abrasive pass readies the surface for the forge. The spine must be dead straight and completely free of deep scratches. Any uneven surface tension could cause the thin steel to warp drastically when the temperature rapidly shifts. The critical moment in any blade's creation is the quench. The steel is brought up to critical temperature, marked by a bright, even luminescence. Plunging the glowing metal into warm oil forces the carbon atoms to suddenly lock into a rigid crystalline matrix. The dark oil cools the steel fast enough to harden it, but slow enough to prevent catastrophic cracking. The violent burst of flame consumes the oxygen at the surface, signaling the permanent transformation from malleable iron into hardened, high-carbon steel. The structure is locked. Following the hardening process and a rough polish, attention shifts to the habaki, or blade collar. This small, specialized copper component is engineered to wedge the heavy sword securely into its wooden scabbard. Pure copper is selected for its high malleability, allowing it to be hammered tightly around complex, asymmetrical shapes without fracturing or tearing. The rectangular plate is folded forcefully over a steel anvil. The hammer blows gradually force the soft metal to mimic the exact thickness and taper of the blade's base, creating a custom seal. The two open ends of the folded copper must be permanently bonded to form a solid sleeve. Silver solder provides a strong, high melting point joint that easily withstands repeated impacts and weather expansion. As the torch heats the copper, the metal expands slightly, opening the microscopic grain structure at the seam. Capillary action draws the molten silver deep into the tight joint. This creates a structural bond that is virtually seamless, ensuring the collar will never pry apart under the extreme pressures of drawing and sheathing the sword. A small end cap seals the collar, ensuring a perfectly flat mounting surface against the future handguard. Gently tapping the copper seats it firmly against the steel shoulders, eliminating any microscopic gaps where trapped moisture could slowly cause hidden rust. Polishing the fitted habaki directly on the sanding belt ensures its exterior profile seamlessly matches the exact width of the forged blade. The tight mechanical tolerance here is not just an aesthetic choice. A loose collar transfers violent impact vibrations directly down the tang, which would ultimately shatter the wooden handle from the inside out. A secondary spacer, the seppa, acts as a washer to distribute pressure across the handguard. The central slot must perfectly trace the geometry of the tang. Thin metal files carefully expand the punched hole, shearing off microscopic layers of copper. A strict friction fit guarantees that none of the heavy metal components will ever rattle or shift during use. The abrasive belt quickly shapes the outer perimeter of the copper spacer. Removing sharp, unrefined edges prevents the thin fitting from digging into the primary handguard or splintering the wooden handle. The smooth, rounded profile acts as a structural fulcrum, distributing compressive assembly forces evenly throughout the entire hilt. The primary handguard, or tsuba, demands a much heavier material. A thick wedge of rusted scrap iron provides the necessary mass and defensive strength. Using an abrasive disc, the craftsman roughs out the circular profile from the oxidized plate. Iron is substantially harder and more abrasive than copper, requiring deliberate, heavy cuts to isolate the central disc from the decaying waste material. Locating the absolute center prevents the finished sword from feeling unwieldy or unbalanced in the hand. The heavy iron plate is bored through, creating a crucial access point for the hand files that will eventually shape the precise tang slot. The harsh, mechanical angles are ground away on the belt sander, establishing the traditional rounded silhouette. A well-balanced tsuba protects the hand, but it also acts as a crucial dynamic counterweight. The dense iron mass pulls the blade's center of gravity slightly back toward the wielder, making the sword faster and more responsive. The thick iron absorbs and dissipates the shock of a heavy impact before those violent forces can reach the delicate wooden core of the handle. Heating the shaped iron to a dull orange stress relieves the metal and burns off residual machining oils. It leaves a textured, matte finish that naturally resists future rust. The core of the handle requires a stable, straight-grained wood that won't shrink or warp over time, splitting a solid wooden block directly down the center. Guarantees that the two halves share the exact same expansion, rate, and cellular orientation. A perfectly straight cut ensures the structural seam will vanish entirely once the two halves are reassembled around the steel tang. A channel is meticulously chiseled out of the inner faces to house the tang. This rectangular recess must mirror the steel perfectly. Any empty void inside the assembled handle allows the heavy blade to shift, which can easily shatter the wood under the tremendous force of a swing. Straight, clean cuts ensure a locked, permanent fit. Once glued and sanded flush, the handle is capped with a fuchi, a metal sleeve that prevents the wood from splitting outward. A thin ribbon of copper is hammered directly around the wooden contour. Shaping the metal securely over the wood guarantees a zero-tolerance fit, binding the fragile end grain in a permanent state of high compression. Closing the copper ring with silver solder locks its final dimensions forever. Pressed tightly onto the wooden block, this solid collar absorbs the forward momentum of the hand, safely directing kinetic energy into the steel. A single mechanical pin will eventually hold the entire sword together. The bore hole must be surgically clean, passing precisely through both the wood and the enclosed steel tang. A dark, penetrating stain is rubbed deep into the outer grain. This oil-based finish seals the open wood pores, blocking out atmospheric moisture that could cause internal swelling, rot, or catastrophic structural failure. High-carbon steel is exceptionally sharp but highly susceptible to rapid oxidation. A thin barrier coating prevents ambient humidity and acidic oils from the hand from etching deep rust pits into the polished surface. The final marriage of steel and wood. The handle is driven onto the tang, compressing the iron guard and the copper collars into a single, rigid unit. A tapered brass pin is hammered completely through the assembly. This single piece of brass acts as a mechanical shear pin, locking the heavy blade inside the handle while remaining slightly flexible. If the impact forces ever become too great, the soft brass pin will absorb the shock and deform, rather than transferring that destructive energy back to the brittle steel. The ultimate cutting edge is established by hand on wet water stones. The water suspends the microscopic steel shavings in a fine slurry, preventing the abrasive pores of the stone from clogging. This patient honing refines the steel to a razor apex. Wrapped tightly in traditional cord, the finished wakizashi catches the light. The rusted automotive suspension spring is entirely forgotten. A sword is an exercise in unified geometry and material limits. What was scrap steel is now a functional instrument, balanced, hardened, and locked into perfect alignment. Order forged from decay.